Hello everyone and welcome back to SWEcodes. So I'm Kaushal Kumar working as software engineer in Airbus. So this video is in continuation with the binary search series and we are having our first problem of the binary search series. So hope you have watched the previous video and make sure you have watched the previous video to get this new technique that I have defined in the previous video and a new perspective of thinking binary search. So now we are back with a problem. The problem is to find the first and last position of element in a sorted array. What does that means? Like we are given an array of integers num sorted in non-decreasing order, that is ascending order, and we want to find the starting and ending position of the given target value. That means this array is containing duplicates. This array is containing duplicates, but it's sorted. And we want to find the first index and the last index of the element. And if target is not found in the array, then we want to return -1 comma -1 as the first and last index. So if you have watched the previous video, then we have defined a new way of thinking binary search, and let's try to apply this in this video. Just quickly open, I'll just quickly see the output, see the input. Yeah, I'll just quickly open OneNote and we'll just write a input elements is something like 5 6 7 7. Now we have 8 8 8, let's say 8, then 9, then 10. So what we want to do is like we want to find the first index and the last index. So let's define this in two search. Let's search for the first index first. The first index, the search for the first index, if you can think of something like this as false false and false false, and this as true, all trues, then you already know that with our technique will be returning the first true value. That means it will return it will return the first index of that element. It will return the first index of that element because we have defined our conditions such that our condition is f of x equals to x greater than equals to target. That means from the element, if it's equals to target, will start having true values. So since this is the first true value, so this is the first position, this is the starting position of the element. So this is very simple. You can get the starting position with the code that has been used in the previous video also. So it's very simple to get the first true value here. Let's define something for the last. So we'll use the technique from previous video. It will give the first true value. We'll have the first true value and it is the starting position. And suppose we do not get the first starting position. If we do not get the starting position, that means element doesn't exist in array, then we'll return -1 comma -1. But if we have the element, that means it will must have the starting point and the ending point, whether if it is duplicate or not. If it is single element also, then that index would be the first and the last index of that element. Okay, so this is for the first occurrence. Let's think something for the last occurrence. So how will think something for the last occurrence? So I'll write again the inputs. So inputs will be something like 5, yeah, 5 6 7 7, then 8 8 8, then 9, and then something like 10. We want this value. But if we define condition like this, we know that this is the first true value, but we don't know we cannot find the last index, because the last true value will be this, and this is not the last index of this 8. So we want to find the last index of the 8. So let's try to modify the function. So let's try to define a function such that x is only greater than target. So what happens in this case? Is like we'll have everything less than equals to as false. So we'll have this as false, this as false, this will also be false, so this will also be false, this will also be false, this will also be false, but here we'll have true. here we'll have true. This will be true and this will be true. So if we think carefully, with our technique we'll get the first true value. With our technique we'll get the first true value. And if you think carefully, so if you define our conditions such as x is greater than target, then you can see that we'll have a series of false then series of true, but this first true is not the answer. But we can guarantee that if element exists in array, if 8 exists in array, and we got with this condition, will get the first true value. So we can assume that if we get the first true value and element exists in array, that means it's very simple. You can see that means if we'll get the first true value, then the previous element will be last false value. You see, the previous element would be the last false value. And if 8 exists in array, and with this condition we are getting first true value as something greater than 8, with this condition we'll get our first true value with something greater than 8, that is 9, greater than 8. And we know that it is the minimum value, satisfying the condition, that means x is greater than 8. It is the minimum value satisfying this condition, that x is greater than 8. That means the element before this 9 must be 8. If 8 exists in array, the element before the first true value, that means the last false value must be 8, because we have defined our conditions such that x should be greater than 8. And if we got the first true value as 9, since 9 is the first value greater than 8, that means the previous value must be 8 if it exists in array. And if it doesn't exist, then we'll return -1. But if it exists, then it should be the last occurrence of that element. We'll see. So we'll have the two low and high values. So our high value is something like nums dot size -1, yeah, yep, while low is less than high. What we need to do, it's like we need to calculate mid. I'll do this. Okay, high minus low by 2, yeah. And if what would be our condition, for the first occurrence, our normal condition is if nums of mid is greater than equals to target, then what we need to do is like we need to do high equals to mid. Why you are doing high equals to mid? Because we want to find the first true value, and mid, since mid returns true value on this condition, then we don't know it's the first true value or not, so we have to include mid, but we have to exclude everything right of mid. So how will you reduce your search space so that you exclude everything right of the mid, but you include mid? So high equals to mid, otherwise else we'll do low equals to mid plus 1, and we will return this low. We'll later on check on the driver function whether this low is returning the correct or not. So whether this low is returning correct answer or not. So I'll just something like this, yeah. Yeah, do we have something? Yeah. So in the search range we need to find, suppose array is empty, this is base condition, we don't need to worry about it. But suppose array is empty, then you don't have the first and last occurrence, so you just have to return -1 and -1, nothing to worry about it. But we have to now find the first and last occurrence. So how will you find the first occurrence? So first occurrence will be something, we'll call the method. We have written the binary search, here to get the first occurrence. How will you get? Nums and target, you will get the first position. You have to check, because we haven't applied a check here, so you have to check if it is the correct value or not. That means if the element exists or not. If element exists, then it will be the correct value, and if element doesn't exist, it will be the false value. So what we need to check, if nums of first equals to target, nums of false equals to first equals to target, then it's not equals to target. Suppose we check for non-existent, suppose it's not equals to target, then what we need to do is like we need to return -1 and -1, because if first position itself doesn't exist, that means element doesn't exist, and if element doesn't exist, we'll have to return -1 and -1. Okay, and if element exists, we have to find the last occurrence. So how will you use same method to find the last occurrence? Since we have written nums of mid greater than equals to target, but our condition is mid greater than target for the last one. For the last, we have condition x greater than target. So I can write it very simple. It's very simple maths. You can write something greater than target. Suppose I'll write something x greater than target. That is equals to x greater than equals to target plus 1. You see, it's very simple. Simple math. X greater than target, that means from target plus 1, it should be greater than or equals to. You understand? If you understand well, if a something is greater than target, that means that same thing is greater than equals to target plus 1. That means we can use the same method. Since we have something with the greater than equals to, we just need to pass our target plus 1 instead of target. So we can use the same function. You can see we can use the same function. We have defined a function with the nums and target, and our condition is greater than equals to target. So for the last occurrence, what you need to find is like, what I need to find is like, we'll pass the nums as it is, but instead of target, I'll pass target plus 1, because for the last position I want condition, I'll write it here in comments, I want conditions to be nums of mid greater than target, and this condition is equals to nums of mid greater than equals to target plus 1. Yeah, greater than equals to target plus 1. So this will be our last index, but this is not the last index yet. This is the first true value that will satisfy this condition. This will be the first true value that will satisfy this condition. Okay, so we need to check once. So if last nums of last, it's very simple. You just check if nums of last is greater than target. If it is greater than target, that means instead of okay, so I'll just check. Yeah, if this is the condition, if x is greater than equals to target plus 1, then the minimum value satisfying this condition will be the first value after 8. That means in this case it's 9. So if we get the index of first true value, then we have to use index -1 to get the last occurrence of 8. So what we'll do is like, we'll check if it is the first true value or not. So first true value, that means we'll have to check for the condition once again. So if it is the first true value, then what we have to do? We have to do last minus. That means like, we got the first true value here and we want the last false value. So first true value -1 will give us the last false value. It's very simple. Now after this, we'll just want to return our first index and last index. Just try to run it. We have the target spelling is wrong. Let's try to run it again. It's accepted. Let's try to submit it. Yeah, it's accepted. So I hope this video is clear to you guys, and how we are reusing those techniques and how we reuse this function to find the first and last occurrence. So with that technique, I guess it would be very easy to find the first and last occurrence of an element. So if you love the concept, please do like, share and subscribe, and please provide your valuable feedbacks. If at any point you don't understood anything, any condition or any statement, you can ping in the comments and I'll definitely reply. So see you, and see you in the next video. Bye.